Okay, guys, how we doing? We are taking a look at this quiz that you guys took. For some of you guys, it went awesome. Other people struggle with it. And I don't want you to feel bad. I want you to feel like you're learning stuff in here. So let's get into it. Let me help you out with this. I'm going to just blast through this, and I'm going to go fast. So you can stop and pause it and rewind as much as you want, but I'm going to go quickly. And I will stop and tell you when I'm talking about math and when I'm talking about physics. So I'm going to start with physics. We're going to color code this thing, and I know that whatever pressure I have here of 120 volts, that pressure will be the same until it hits something. As long as it's in a conductive path, that's 120 all the way. Same thing down at the bottom. It's 0 down here, so it's 0 until that current hits something, not until it hits a resistor. Then we're going to drop this down up here. Orange, there's nothing magical about the color orange. We're just trying to show that it's a different color, so the voltage is dropping. I think on the other side of the blue, we'll have green going up like so. And then right in that middle spot, we'll do yellow. So again, there's nothing magic about these colors other than we know that wherever the colors are the same, the voltage is the same, the pressure. Where the colors are different, there is a difference, hence a voltage drop. That voltage drop is the thing we're going to keep coming back to. I'm not sure everybody understands the difference between voltage and voltage drop. And I'm going to say it a million times here in the next 15 minutes, so hopefully you'll get it. All right, so that's one thing we know. Now what we do, that's all physics. Now it's math time. When we look down here, the formula that we're using is, of course, V equals IR. There are only 3 things there. So if you know any 2, you can always find the other mathy-wise. But we only know 1. We only know the resistances. Oh, wait a minute. Physics time. I do know that the total resistance drop is 120 volts. It goes from 120 to 0. So we're going to write 1 to 0 there. Well, still, I can't do any math yet. Time to do some physics. All right, so now what I want to be able to do is simplify this. And I want to be able to draw this as a very simple series circuit that looks like this. We're down here, this is 6. This is 7 and 8 together because they're in parallel. And this chunk is 1 through 5. Because you can really look at it sort of like the current comes out of here, then goes through this whole chunk. You know, some splits there, some splits, but it does all this stuff, kind of goes through, and then it all comes back together over there and joins back up, and then it's the same again there. So we're going to treat this whole big chunk as just that and simplify that. All right, and we're going to do the same for the bottom. We got 7 and 8. Whatever current comes through here is going to split through there and then come out the other side and join up again. So we're going to take that big chunk and represent it as 7 and 8. So when we do that, we start doing our math. And this is some math stuff where we know that 1 over RT equals blah, blah, blah in parallel. And in series, you add them up. I can find that these 2 up on top act together as if they're 147. These 2, 3 and 4 together act like one that is 89.7. Therefore, 3, 4, and 5 all together act as one that is 340 ohms. And therefore, all 5 of these act together as one path that has a resistance of 102 ohms. So I'm going to clean that up a little bit now that I've done all the math. And you can slow that down and watch it on your own if you want. I guess I'll leave that up there. Let's go 147 there. We'll need that. I'll leave this 89.7 here. I'll leave this 340 there. And this is the number that's going to help us. That is the 102. That says this whole thing is 102 ohms. Number 6 by itself is 22.5 ohms, I think. Is that what it says? That's what it says. Number 7 and 8, we're doing this whole thing again, 1 over RT. We know that they're going to act together like a resistor that has 45 ohms. So what that lets us do is now we can add these things up. All that current is going through there for a total of 170 ohms. And now we know 2 things. So I can find the third, 0.706 amps. So that's a good deal because now I know the total resistance and I know this total value of current that's going through this circuit. All right, that was math. Let's get back to some physics. Looking at this circuit, is there any one resistor of all of them that's getting all of that current? And the only one that is number 6. That's the only one where it's not split up. So I can say 6 is getting that total current of 0.706 amps. Yay. Wait, now we know 2 things about that. Let's do some math. So now we can find the voltage drop is 15.9 volts is dropping across resistor 6. All right, if you're not sure what I'm doing, slow down, go back, rewind, watch again. All right, so now we know a little bit of information. We know the total amount of current flowing, we know voltage drop across 6, but we've got more to do. So you've got a top chunk that has 5 resistors, that's kind of complicated, and a bottom chunk which has 2 that are connected in parallel. That's complicated, but not as complicated as the top. So let's do 7 and 8 right now. Okay, we know these two act together like one resistor that has 45 ohms. Those 2 parallel branches together act like one. We know the total amount of current that's going through it is 0.706 amps. Remember, we figured that out going through 6. That 706 amps is going to split up like this and come out the other side complete. But we don't know exactly how it's going to split up, 7 or 8. 7 has more resistance, so it should get less current, but we don't know how much less. But we do know this. The total resistance of both of them together is 45 ohms. The total current is 0.706 amps. So that means the voltage drop across both of them is 31.8 volts. Why do they both get the same voltage drop? Well, because of the way they're connected in parallel. That's physics. Do you know your physics? All right, now for both of these, they have been, we've got 2 of the 3, so we can go ahead and figure out that 0.272 amps flows through the 117, 0.424 amps flows through the 75 ohm resistor, and hey, if you add those 2 up, what do you get? 0.706, which is what it should be. Remember, we're getting all that current through 6, it splits up a little through there, adds back up, and it should be the total amount. All right, can you dig what I'm laying down so far? So we're moving places. All right, I'm going to clean this drawing up a little bit up here on top. Let's see if I can do this, because there's some things I want to do. I want to make a little bit of room. Okay, what we know now is that we have a voltage drop across this last resistor. And I know that the voltage is 0 over here, and the change in voltage here was, we just figured it out, 31.8. Which means the voltage on this side must be 31.8 volts. If the drop across 7 and 8 is 31.8 and it ends at 0, it must have started at 31.8. That's helpful because it tells us that on this side, the downriver side of 6, it's also 31.8 voltage. That's what the pressure is. And we've already calculated that the voltage drop across 6 was 15.9 volts. So that means on the upriver side of that, from 31.8, well, we can add those 2 together. 31, here's math time, this feels good. 31.8 plus 15.9 means up here, the voltage in this part is 47.7 volts. All right, that's math. Now that is the voltage, that is not a voltage drop. But we do know this, physics time. Due to the color coding, we can see that the drop from here to there is from 120 to 47.7 volts. We know that the drop from this position to that position is also the same 47.7 volts. Or I'm sorry, 120 to 47.7. So for both of these branches, we would say that the voltage drop is, what's 120 minus 47.7 equals 72.3 volts across that branch, across this entire branch. So for that branch, we know the voltage drop is 72.3 volts. We know the total resistance because those 2 acting together act as 147 ohms. So we can find the current through those as 0.490 amps. Now, here's where some physics comes into play. If 0.49 amps is flowing through 1 and 2, they both get all of that current. So we can say 0.490 amps, 0.490 amps for each of those because they're in series, so they both get all the current. That's what's happening. And now we know 2 things. You can do your math. We've got a voltage drop of 23 volts. Hold on. 23 volts across voltage or resistor 1, and 49 volts across resistor 2. All right, now we're going to keep doing the same thing. We know that for this whole chunk, this is the most complicated branch we got there, a certain amount of current goes through, breaks up, rejoins, and goes through. So if we can find the total resistance of 3, 4, and 5, and I think we already figured that out. I think it was 340 ohms. And we know the voltage drop across that is, again, that 72.3, because it's going from 120 to 47.7. Now we know the current through that branch is going to be 0.212 amps. I know this is crowded. So now you got to ask yourself, in that branch there, did any of those resistors, 3, 4, 5, get all of the 0.212 amps? Yes, resistor 5 gets it all. So let's put that in there. 0.212 amps. Hey, look at that. Now we know two things. We can do some math. That means that the voltage drop across resistor 5 is 52.9 volts. But remember, the voltage drop across this entire branch is at 72.3 volts. And we know that 5 is getting 52.9. So we know that the drop across 3 and 4 has to be 19-ish. What's 72.3 minus 52.9 equals 19.4 volts. So now we know 3 and 4. 19.4 volts, 19.4 volts. Now, math time, you know those two things. And we got 0.136 and 0.176. And that makes sense. You're going to get, wait a minute, does that make sense? 0.076, my bad. All right, that makes sense because the one with the higher resistance gets less current, but the two of these things have to add up to what's going through number 5, and it all checks out, my friends. So that's a mess. You're not going to be able to skip to the end of the video and look at this and have it make any sense. But if you watched me as I went through it, hopefully you understand where I was switching between math and physics. And really knowing the difference between voltage and voltage drop is the deal. So I'm going to put a few more of these up in the Makeup Center. And if you don't like your score from the first one, you can take it again, but only once. I don't want you thinking you can just get up there and just, let me see what happens. You got to be prepared. So go and do extra versions of this. Print them out. You got them on, I posted that thing on Thursday. Print this guy out. Just do it over and over again. Remind yourself of how you can skip between physics and math. Knowing what the voltage drops, how those work, knowing that the current, which resistor is getting all of it, that kind of stuff. And if it still doesn't make sense, come in to see me. Let me help you out, okay? All right, enjoy your day. Let me see if I can get out of here.